The reactions are of two types, elementary and complex. Elementary is one-step reaction, complex is more than one-step reaction. In elementary reaction, molecularity is equals to order of reaction. In complex reaction, slow step is rate determining step and helps to give the rate of equation, has no molecularity significance. What is the difference between molecularity and order? In molecularity, the number of molecules colliding to give the product, that is sum of stoichiometric coefficient of reaction of the step. If the reaction is 2A plus 1B gives B, then molecularity is 3 because 2A and 1B are combining. Theoretically determined molecularity and no effect of temperature and pressure. The order. The sum of the powers of reactants in the rate equation is order. It is experimentally determined and changes with temperature and pressure. Molecularity is always a natural number and order can be negative, 0 or fraction, etc. Molecularity has no meaning for complex reaction. Order has meaning for both complex and elementary reaction. For example, there is a reaction A to product, then rate equals to Ka to the power n. N is the order of the reaction. So the unit will be here, rate unit is mole per liter second, and K is and we have to find the unit of K. Here A concentration, so mole per liter to the power n. So K unit will be equals to mole per liter into mole per liter raised to the power minus n 1 upon seconds. Now K unit is mole per liter raised to the power 1 minus n per second. So K unit is mole per liter raised to the power 1 minus n per second. Now if the order is 0, then unit of K is mole per liter per second. If the order is 1, then unit is per second. If the order is 2, then unit is per mole liter per second. If order is 3, per mole raised to the power minus 2 liters square per second. This is according to the this equation. Now if the n is 0.5, then the unit of K will be mole raised to the power half liter raised to the power minus half per second, according to this, if we put n is equals to 0.5. Now if the reaction is 2N2O5 gives 4NO2 plus O2, then the rate of decomposition of N2O5 will be K1N2O5. Rate of formation of NO2 will be K2N2O5 and rate of formation of O2 will be K3N2O5. The relation between K1, K2 and K3 will be equals to R is equals to minus 1 by 2 d N2O5 upon dt is equals to 1 by 4 d NO2 upon dt is equals to d O2 upon dt. That is N2O5 concentration will be cancelled out. Remaining will be 1 by 2 K1 is equals to 1 by 4 K2 is equals to K3. Then multiplying 4 to each term, then we will get 2 K1 is equals to K2 is equals to 4 K3. Now let delta x upon delta t is equals to dx upon dt, then average rate will be equals to delta x upon dt, then instantaneous rate will be equals to dx upon dt. For the reaction AA plus BB gives CC plus DD. Rate is independent to the amount of species. Rate is equals to minus 1 upon dA upon dt is equals to minus 1 upon B dB upon dt and is equals to 1 by C dC upon dt is equals to 1 by D dt upon dt. Now integrated rate law. For zero order, A gives product, rate is equals to Ka to the power 0 because it is zero order. So K will be equals to minus dA upon dt. For the A gives product, at time 0 A naught is the concentration and P naught is the concentration. After time t, A is the concentration, P is the concentration. This is reactant, this product. Now integral on both side we get of this equation, integral on both side we get this dA integral A naught to AT and K integral dt 0 to t interval. Then it will be minus A naught to AT K T 0 to t. Then minus at minus a naught is equals to kt. Then on rearranging, at is equals to a naught minus kt. Now when time is 0, it is a, then it is b. At after time t, a minus x left, this is b plus x. So rate is equals to k a to the power 0 minus dA upon dt is equals to k minus d a minus x, because we have put a minus x dt is equals to k. So splitting the terms, minus dA upon dt plus dx upon dt is equals to k. So dA is constant, a is constant, so cancelled. So dx upon dt is k. Now a is equals to a minus x. Here a naught is equals to a initially, then x will be equals to a naught minus a. Then putting this value integral on both side, then x is equals to kt. Therefore x is, since a naught minus a, we get a is equals to a naught minus kt. Now concentration of a is a equals to a minus x. X is the charge. Now a is left or minor remain. Half-life period is a for a minus x, and x is equals to half a by 2. A minus x is equals to a common, then 1 minus 1 by 2, that is a upon 2. The quarter life period a minus x will be a minus 4, that is time period is 3 by 4, reduced by x change completion, reduced to a minus x left. Half-life period t half is equals to a minus x, we will put a upon 2. X is equals to kt, we know x will be equals to a by 2. When t is equals to t half, x is equals to a by 2. So putting this in this equation, a by 2 is equals to kt half. T half will be equals to a upon 2k. That is a is initial concentration. So T half is equals to a naught upon 2k. Quarter life period is equals to a by 4. A minus is equals to a by 4. So x will be equals to 3a by 4. So put in this equation x is equals to kt. We put x is equals to 3a by 4. T is equals to t quarter. So t quarter is equals to 3a by 4k. That is 3a naught upon 4k.